Hi, everybody. All right, so today we're going to talk about documentation. Okay, so first of all, documentation is once your design has been approved and fully researched, the part needs to be prototyped or manufactured to show that it works. To do so, we need to have the appropriate documentation to communicate the idea to everyone in the company. So you've got to be able to make something. So the drawings, it's your drawings. Okay, so drawings need to have everything on there so someone else who doesn't even know what it is can make that part from just your drawings, okay? So documentation is the most difficult, time-consuming, yet most important part of the engineering communication, okay? This documentation is done with what's called working drawings. So working drawing is a complete set of drawings that document how the object will be manufactured and assembled. Each are going to include part drawings, assembly drawings, parts list, and then any kind of specifications or instructions needed as well. A part drawing is the drawing. So the different drawings. So we talked about part drawings, assembly drawings. You guys know part drawings. You know assembly drawings. We've talked about part lists already. Okay. So, but just to make sure you understand a part drawing, it's a drawing that consists of the information for making just one part of the design, one thing. Okay. Then that gets assembled into other things to make the entire product. So this drawing consists of dimensioned orthographic views, so 3 views, the multi-views that we talked about. If necessary, sectional, possibly an auxiliary, and maybe more likely a detailed drawing, and also an isometric view that can help document the part. All features of the part will be dimensioned. Make sure, and that's the hardest part. To tell you the truth, the hardest part of all of this is dimensioning, making sure all the dimensions that are needed are going to be there. Okay. Here's an example of a part drawing. We talked about this. Here's your isometric is up here. Here's your isometric drawing. Okay. All your dimensions are on here, hopefully done correctly. I don't think this one probably should be done over here like we've talked about. So, but anyhow, that's the idea. So now let's talk about what goes into our drawings. Okay. So you've got these different things. You've got your border coming around there. You've got this part right here, in here, and so forth. So let's talk about what the different things are called so you understand what that is. So first of all, title block. Title blocks are necessary to identify the drawing and the general details that go along with that part. An example showing the part of a title block is shown here in the next slide. Here's an example of your title block. On our Project Either Way one, it's that line at the bottom with all the information given. That's called a title block. Okay, so an example, here's an ANSI. This is actually one that Inventor has with it. The default one they give you, okay? So it's got the name of the person who checked the drawing. It shows what sheet number is, because most likely, remember we talk about we have the different sheets on the left side. One set of drawings is with a bunch of different sheets. This keeps track of that right here. This would keep track of those sheets right down here. The scale, there's a scale 1 to 1. In this case, was full size. Could be 1 to 2, could be 1 to 3, could be 1 to 4, or 2 to 1 if it's a smaller part. The number or a specified part name goes right. I'm sorry. The title of the project goes there. This is where that goes. This is the drawing number or the part name in relation to the total drawing. So, for example, if you have a overall project, you've got different drawing parts that go in it. That's what will go down there. Any kind of zoning is used to specify location on the drawing, usually shown in numbers. Oops. Another person will check, possibly another check. Final one, your boss, supervisor, approving the drawing, saying it's ready to go out. And then the revision numbers. So a lot of times a product is not done with the first drawing. Okay, you find out there are things that don't quite fit, so they got to redo it. So that would be a second revision, third revision, and so forth. And then that's the size of the paper. A size is basically 11 by 17 or 12. They call it 12 by 11.5 by 11.5 by 12 would be, or 11.5 by 8, 8.5 by 11. So 9 by 11, 9 by 12 is what they would usually refer to as A. And then B is going to be, 17 by 11, and then so forth like that. Okay, there's ways to figure that out. And then any kind of general notes. In this case, they're talking about fillets and rounds. Assembly drawings, those are the next ones. We've talked about how you put the assembly together, how we put the drawing. So assembly drawings show how the parts of the component design fit together, how they go together with the explosion. Generally depict at least one orthographic projection, and there's generally a full section view is also shown in the assembly drawing. Here's an example of assembly drawing right here, showing how all the parts go together. So you get the bubbles showing that part there is number 7. So if I look in the parts list down here, I've got 7, that's your cylinder, and so forth. They've got a sectional drawing here showing what the inside of it looks like, and then all the different bubbles of all the different parts, so it shows how it goes together. Okay, the information that goes on the assembly drawing is one or more views, including generally a sectional or possibly an auxiliary, and a large view of the small details, so that'd be a detail drawing. Overall, the specific dimensions for the assembly. That's the overall. If you look here, you got they're not showing dimensions, but if you were doing it, it's going to be the overall, how big the overall product is. Balloons indicating the numbers. That's the balloons right here, the different numbers with the circles around it. Those are called balloons. And then the parts list, or possibly the bill of material. Here's your parts list over here. Okay. Shows the part name, how many of those quantities, how many of those parts are in it. Over here is what sheet it would be on. So what sheet number is the actual part on within the set of drawings. Okay. So types of assembly drawings would be a design assembly, general assembly, detail assembly, erection assembly, subassembly, and pictorial assembly. So design assembly shows the relationship between all the components and how they work together. Okay. Design assembly often based on preliminary design, possibly sketches that they've done. A general assembly is the most common type that we'll be using. Those are the types that we've actually been using. Display the multiple view drawings, sometimes with a sectional view. That's what's going on here. So we got the top right here. We got the front right here, and then we got the right side, which is a sectional drawing. A detail assembly combines an assembly draw a view with several parts as dimension multi-view drawings. Reduce the number of drawing sheets that are needed, because most of the stuff is done on one sheet, and more appropriate for design, generally with smaller or less components. Here's an example of a detail assembly drawing. An erection assembly is similar to the general assembly, except dimensions and fabrication specifications are commonly included. Typical association with cabinetry or products made from structural steel, a lot of times used for fabrication and assembly. Here's an example of that right here. So here's a subassembly. Pictorial assembly is usually an isometric or perspective drawing. Can be rendered, or it might be actually a pen drawing one, or possibly even a photographic quality of it. It actually gives you an idea of what the part actually going to look like. Used usually in sales promotion, possibly to show a customer how things go together, and also possibly how to maintain the product. Okay, a pictorial assembly, often used in catalogs, journal articles, and advertisements. This pictorial is a section to show the interior designs of it. An exploded pictorial assembly, that's what we've done in the past to show the different parts. You can see the little balloons on them up here. Where's my mouse? There it is. You can see the balloon pointing to that part. That's part number 15 right there. And it's everything exploded apart, showing how it would actually go back together. We talked about the balloons already. There's circles with a single number connected to it to show what part it is inside your parts list. It's done with a circle with a leader line going to the part that it's pointing out. Balloons on a drawing are always the same size. Inventor always does that. Balloons grouped in an easy to read pattern. Try not to put them over each other, make it real easy to read. The numbers correspond to the item in the parts list, and the balloons do not have horizontal or vertical leads. You can see how these leaders are going off on an angle. Okay, there's nothing going straight up or straight to the right or left. Straight to the right or left. Okay. A parts list is a table with information about each part contained in an assembly. The item numbers correspond with the balloon numbers. Here's an example of a parts list. Now, sometimes they have a lot of information in there. In this case, they're showing the material. They're showing the description of what it is. You can see right here, it's talking about a thread pattern on that with that cover plate screw. Okay. So depending on a lot of times, and pretty much what we've done is we've said quantity, item number, quantity, and name. That's all we've done. They could also sometimes put the amount, the cost of the different parts. Okay. Parts list generally have an item number from the balloon, a quantity, how many of that part is in the with the product, part or drawing number as reference to the detailed drawing. So what page the actual part would be, the detailed drawing of that part would be on. Description, we talked about that. Material identification of a part, and possibly information about vendors or cost. Location of the parts list specified by the company standard. Generally, most companies tell you where to put them. We've been putting them in the lower right corner of the product, but generally either above the title block. That's where we've been putting it on the right side, right above the counter title block. Possibly the right corner, upper left corner. But basically just keeping it out of the way so you can get everything else and see everything else that's going on in the drawing. Here's an example of one of them right here. The parts list is right there. And that's this one. Okay, and then I'm going to show a different one, another one in a second here, talking about constraints and stuff within Inventor, and also Onshape. We talked a little bit about that already.